This video will be about particle motion in calculus. What is particle motion? Straight line motion can be modeled by giving position as a function of time. Calculus helps us learn about velocity, speed, and acceleration, all from our knowledge about the change in position. Some key terms to know are position, velocity, acceleration, and speed. Position determines where a particle or object is located on the x-axis at a given time. Velocity determines how fast the position is changing at time t and gives the direction of movement. Acceleration determines how fast the velocity is changing at time t and shows if the velocity increases or decreases. Velocity is a vector that has magnitude and direction, but speed is a scalar that expresses the absolute speed of an object. So here is an example of particle motion. We are given the following position function measured in meters. S of t is equal to t to the third minus 3t squared minus 2. So what is the object's initial position? To find this, we substitute 0 for t, and after substituting, we get -2. When t is 0, the position of the particle is -2 meters. Let's determine the velocity of the particle by taking the first derivative. Taking the first derivative of the position function leads us to get the velocity function, which is 3t squared minus 6t. So when is the particle at rest? Let's find out when the particle is at rest by taking the velocity function and setting it equal to 0. After setting it equal to 0, we get 0 is equal to 3t squared minus 6t, and we can factor out a t. And solving for t gives us 0 and 2. So the particle is at rest at time 0 and 2. So when is the particle moving left and right? We found critical numbers when we found when v of t is equal to 0. If we test for positive or negative values on either side of our critical values, we will be able to determine when the particle is moving right or left. When velocity is positive, the particle moves right, and when velocity is negative, the particle moves left. So after making a sine graph, our sine graph shows us that since the velocity is positive to the right of t of 2, the particle is moving to the right on that interval. Since the velocity is negative between 0 and 2, the particle is moving left on that interval. Let's determine the acceleration of the particle by taking the second derivative of the position function. So taking the second derivative of the position function, we get the acceleration function, which is 6t minus 6. So when is velocity increasing and decreasing? To find this, first let's set the acceleration to 0. And setting it equal to 0 gives us 0 is equal to 6t minus 6. And after solving for t, we get t is equal to 1. To determine the increasing or decreasing intervals of the velocity, all we have to do is find when the acceleration is positive or negative. This means that the velocity is increasing to the right of 1 and the velocity is decreasing from 0 to 1. When is the speed increasing and decreasing? When the particle's velocity and acceleration have the same sign, the particle's speed is increasing. When the particle's velocity and acceleration have opposing signs, the particle's speed is decreasing. So if we compare the two sine graphs, velocity and acceleration have the same signs from 0 to 1 and also to the right of 2, meaning the particles are increasing in speed in that interval. Velocity and acceleration have opposite signs between 1 and 2, meaning the particle speed is decreasing in that interval. Distance versus displacement. What is the difference? Distance, or total distance, measures the length of a particle or object's path taken over a period of time. Displacement measures how far the particle or object traveled, regardless of change in direction. And this is a picture that demonstrates distance. versus displacement. So the equations for the two, to calculate displacement, substitute the ending and starting times into the position function and subtract them. To calculate distance, calculate the absolute value of the difference in position between all resting points, and then you would add them together. So that leads us to the end of the video. Thank you for watching, and I hope that was helpful.